Hey, Danny.
Hey, Professor. Are you doing okay?
Yeah, just sleepy. How about you?
Uh, I'm not too sure how I'm doing anymore.
Oh, what is that? What does that mean?
Yeah, I have no idea anymore. I don't know. I don't know.
Well, hang in there. Hope everything gets better.
Uh, I do have a few questions for you, but it's not about this class, if that's
Sure,
okay.
sure. What's up?
I have my senior design project this semester,
Hmm.
and I believe that my project itself will need to use ANSYS.
Okay.
And Professor Jinwoo Lee sent me to you
Hmm.
for any questions about ANSYS,
Sure.
because I think ANSYS isn't a required class. I don't believe so.
It's not. No, it's 410, and so it's an elective, but yeah, it's not required.
Yeah. So I think from my conversation with Professor Lee, it seems like we might have to learn ANSYS. I
Okay.
know that I can watch your videos online, but I just wanted a gist of if like ANSYS is a little different from SolidWorks.
It is, yeah. And so ANSYS is more focused on doing physical. You can think of it as almost like virtual experiments. And so a lot of times, like when you build a structure, you're wondering, is this actually going to hold up in real life? And you want to know things like what are going to be the internal stresses and how much is it going to deflect or deform
Right.
in once you install it into its real situation. And so finite elements kind of gives you a way to predict that without actually doing a physical test. And so it's the name that people use for finite elements a lot is simulations, and in a lot of ways you're basically simulating reality, and what it could be under those situations, just so that before you build or before you construct anything, whether
Right.
your design is going to hold up or not. So it's basically predictive modeling or predictive simulations.
Okay. So for 410, it's basically just like a SolidWorks class where you learn the software and then create some stuff.
Yeah, I've kind of I've kind of changed the class quite a bit, each time I teach it, but I'm starting to focus more on the software. We do cover some of the theory behind it because that theory is important,
Right.
for learning how to use the software properly. But a lot of it is focused on just the software. Yeah.
Okay. Thank you for that.
Yep. Yeah, there's a free student version for ANSYS you can download. It's not the best because it really limits you in a lot of ways, but it's enough to get started. And so I would start with that. There's a lot of good tutorials that you can look up online, and you have me as a resource too. And so I would say just go ahead and download it, give it a try. Start with some really basic stuff. That's what I recommend. So don't apply it to your senior design right away.
Right.
I think that's how people get frustrated with the software is that they try to tackle a really complicated problem first, and then it's really hard to set up, and they get frustrated and then they give up. So start with some really basic stuff, get the hang of the software, and then you can kind of build up to your scene design.
Right. Thank you.
Mhm.
Professor,
Hey, what's up?
could you explain why we don't extend our analysis to the least common multiple for annual cash flow
Sure.
analysis? Yeah.
Yeah, so we back when we were doing the lecture notes on annual cash flow, we did both. And so we did when we converted to an annual cash flow, we tried one where we did the least common multiple approach and another one where we didn't, and we ended up with the same thing. And so what ends up happening is that because a annual cash flow is it's a recurring series, it doesn't matter as much, how many years that you do it for, because it's something that occurs on every single year. And so it's you can almost think of it as almost like it's normalized across whatever length that you're considering, because it occurs in every year. Versus a present sum, how much money that you account for in the present, that depends on how far you
Yeah,
go
that
along.
makes sense. Yeah.
Right.
Okay. All right. Thanks.
Yep. Okay, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everyone. How's everyone doing today?
Doing all right. How about you?
Good, good. Yeah, good. Thanks for asking. Yeah, yesterday it's been
True.
hot,
It
man.
is
Like,
not as hot as yesterday.
yeah, I know it's been really hot. You would always think at this time of year that things start to cool down, but I remember talking with Dr. Sanders and Dr. Lee at we get lunch every week, and it's not until like November that we're like, okay, the weather's finally cooling down, but yeah, it just stays hot. Okay, and so the plan for today is we are going to continue our lecture notes on rate of return. Okay, we have quite a bit left, and so I don't think we'll finish all of it, but we'll get as far as we can. Okay, and then we'll go from there. Okay. So the rate of return stuff, I'm not sure if I mentioned this before, but the rate of return stuff is not going to be on the midterm. And so the midterm is just going to cover everything up until annual cash flow, right? And so basically the homework 3, that's the last of what you should, what you need to know for the midterm, okay? And so remember our midterm is going to be a week from today, okay? It's going to be a virtual exam that you'll take over Canvas, and it'll be a 90-minute exam. And so the exam will start at 1 p.m. and then you'll have until 2:30 to finish everything up and upload stuff to Canvas. All right. Oh, okay. Oh, so the hot weather's ending soon. That's good. The sooner it ends, the better. Okay. All right. So for the midterm, remember it's an individual endeavor, and so please don't I don't mind if you guys study together before the midterm, but once the midterm begins, please, try to, or don't try to, make sure that you don't talk to anyone. Okay. And so, with the whole virtual thing, I've had a lot of, issues over the past, year and a half of, people posting questions on Chegg and people copying answers off each other. So, I know this is going to be another virtual exam, but just please don't do any of that. Okay. Because there have been instances in the past where where I've caught people doing that, and I've unfortunately had to take action just because of the policies that we have in our department. Okay, so I'd rather not do that again this semester, and so please make sure that you're doing your own work for the exam. Okay. All right. So any questions? Any other questions I can answer before we get started today? Yeah. So the exam's gonna be Thursday next week, so it's 1 week from today. Mm-hmm. Yeah, you guys can look forward to the review video tomorrow afternoon. Okay? So remember, the poll closes tomorrow morning, and so if you want to make sure that your voice is heard for what you want me to cover during the review video, make sure you get that in before tomorrow at 8 a.m. Okay. Okay. All right. And so let's pick up where we left off. Okay. So actually, we left off in the middle of an example, and so let me just go back a couple pages just to show you where we were. Okay. And so let me clean this up a little bit. It's a little bit busy. Okay. All right. And so in this example problem, what we have is this cash flow diagram. Right. And so you can see we have 4 positive cash flows at the beginning of the cash flow diagram on years 1, 2, and 3. And those are totaling $9,000, right? Or they're $9,000 each. And then we have a uniform cash flow that's negative from years 5 through 9. Okay. All right. And so what we want to do in this problem is we want to compute the rate of return. Okay. And so this one's a little bit more complicated than the simpler examples that we did before this. And so the whole point of this example was to show you what are methods that you can do to compute rate of return when it's not so simple. Okay. And so the way that I usually like to do these problems is I like to set up I like to compute the net present worth of all the cash flows, right? And so in the formula on the bottom right here, okay, you can see I have a formula for the present worth, or PW, and I've converted all the cash flows into a present sum, right? So you have a $9,000 that's occurring at year 0, and then you have a positive $9,000 that's a uniform series from years 1 through 3. And then you have the negative 8,316 cash flow from years 5 through 9. And that you have to convert twice. Okay. All right. And so what we said was, because we're interested in solving for the interest rate, right? Because we don't know I in this case. What we're going to do is we're going to take these 3 conversion factors that I've boxed here in this problem and start looking up conversion factors from the compound interest tables, and then find the interest rate that gets us closest to 0. Or if not, the one that, if not, try to find the point at which the sign of the present worth changes either from positive to negative or negative to positive, right? Because ultimately, what we want is we want to solve for the interest rate that satisfies this equation And most likely, for most cases, it's not going to be a nice whole number. And so you're not going to find something that's in the tables that's going to satisfy this completely. But you will be able to find exactly where approximately where it lies. Okay, and so once you find those bounds, what you can do then is you can interpolate in order to solve for that rate of return. Okay, all right. And so, unfortunately, there's no elegant way to go about this. And so you kind of just have to start plugging in values. Okay. And so on this next page, what we did was we started plugging in different interest rates and then computing how that affects our present worth, right? And so we started with an interest rate of 1%, one of the lowest that we can go. And then what we got from this was a negative $3,314.60. Okay. And then we said, okay, that's not that close to zero. And so let's go ahead and keep continuing. And so from there we have an interest. And so from there we checked our interest rate of 2%. Okay. And then from 2%, what we got was a present worth of negative $1,250.78. Okay. Right. And so we're not quite there yet, but we are getting warmer. Okay. And so we are getting closer to zero. And so let's check one more interest rate. Okay. And so the next one on the table is 3%. And so we compute the present worth using an interest rate of 3%. And then what we got was a positive $620.45. Okay. And so what I said at the end of the lecture on Tuesday was that, in between 2 and 3 right here, we can see that the sign of the present worth changed, right? And so we went from a negative $1,200 to a positive $600. Okay. What that means is that the true rate of return is somewhere in between 2% and 3%. Okay. Okay. Right. Because somewhere in between 2 and 3% is the interest rate that satisfies the present worth equation exactly. Okay. In other words, it's gonna give us a present worth of 0. But now that we have these two, I would say these two outer bounds here, right? So one on the negative side, one on the positive side. What we can do from here is that we can just simply interpolate between these. Okay. Right, and so by interpolation, we'll be able to solve for the the true rate of return. Okay. And so I'll show you the formula for that on the next page. Okay. All right. Any questions on this? This is just a recap of what we did at the very end of lecture on Tuesday. All right, question. So is rate of return only for present worth? You can also set it up for an annual cash flow too. And so you can convert everything to a uniform series and then compute rate of return from that as well. So they both work just fine. And so the only thing is that, oftentimes for these rate of return problems, you'll be given a cash flow diagram, something like this, or if not, that you can draw the cash flow diagram from the problem. And then what you want to do is you want to solve for the interest rate that balances this cash flow diagram. Yeah. Mm-hmm. Okay. Okay, so let's go ahead and interpolate. Okay. Right. So actually, let me just go ahead and write the data here, just so that we can have it. And so the present worth that we got when I is equal to 2%. Okay. What we got from that was a minus $1,250.78. Okay. Right. And then the present worth that we got when I is equal to 3% was $620.45. Okay. And so what we want to do here is we want to interpolate in between the two. Okay. All right. And so if you guys have taken thermodynamics before, I know you guys have done interpolation. But let me give you the formula that I use for this, just so we can all be on the same page. Okay. And so the formula for interpolated rate of return And so the symbol I give for that is IRR, which stands for internal rate of return. Dr. Banks loved interpolation. Yeah, and you teach thermodynamics. It's part of your it's a part of your way of life. It's interpolating. I haven't taught thermo here yet, though I think it's going to be in my future someday. And so, you know, I've done my fair share of interpolating quite as well. Okay. All right, so let me finish up writing this this formula here, and then we'll discuss it. Because it's a little bit of a specialized form of the interpolation formula that you probably are aware of. All right. And so this is how I typically perform interpolation. Okay. And so let's go ahead and define all of the symbols here. Okay. First we have I low and I high. Okay. And so these refer to the lower and higher interest rates on which you're interpolating between. Okay. And so for this case, our lower interest rate here is 2%. And so for I low, we're going to plug in 2. And then for our I high, our high interest rate here is 3%. Okay. And so that's pretty straightforward. Okay. Okay. Here's where people get confused a little bit. Okay. And so we have PW low and PW high, right? And so intuitively, you know, when you read that, I think people naturally plug in for PW low, let me plug in the lower present worth, right? And then for PW high, and we plug in the higher present, right? And so that's what people usually think when they see this formula. But I want you to guard against that, right? And so PW low here, this is the present worth associated with the lower interest rate. Okay. Whereas PW high, this is the present worth associated with I high. Okay. It just so happens in this problem that they match, right? And so in this case, the present worth associated with 2% is also the lower number, or it's the more negative number. But you know, if we had a situation where these were swapped, and so let's say that for PW at I is equal to 2%, we get a positive 1250. And then for PW at 3%, we get a negative 620, right? And so in this case, you know, PW low, even though this present worth numerically is higher than the other one, it's the present worth that's associated with the lower interest rate. Okay. And so don't get confused by the terminology there. So make sure make sure you're choosing the right, you're associating the right one with ones. Okay. All right, but for this problem, they happen to be the same. And so PW, the lower interest rate 2% just happens to have a lower present worth, and the higher interest rate just happens to have a higher present worth. But they could be swapped, and so you know, just kind of make sure you're paying attention to that when you're doing problems. Okay. All right. Any questions on this before we plug in? Okay. All right. So let's go ahead and plug into this formula and then compute the rate of return. Okay. All right. And so if we say that I low here is equal to 2%. And for I low and I high here, you can just plug in the whole percentage. You don't have to change it to decimal because we're simply just interpolating. And so, you know, you don't have to change this to 0.02. Okay. So PW low in this case was our minus 1250.78. And then PW high is a positive 620. Okay, 620.45. Okay. And so we plug all that in. And what we get is a internal rate of return of 2.67%. Okay. And so that's the rate of return of this problem. Okay. And so you can see this is not a nice number at all. And so it's a decimal that's pretty far in between 2 and 3, right? And so for these problems, most likely, unless by some miracle that I choose, miraculous numbers, that you're going to get rates of return that are like this. Okay, and so just be prepared to interpolate a lot for these problems, because it's just part of that. Okay, all right. And so just like we talked about last time, if you didn't want to interpolate, you could also do this problem with MATLAB or Excel, right? Just remember we did the graphical method that we talked about last time. And so if you took our present worth formula and you plugged in the equations for those, and you plotted those as a function of interest rate, then you can find the location where it actually crosses the x-axis, right? And so that would be another way to solve this problem. It depends on if you feel more savvy with MATLAB or if you feel more savvy with interpolation, right? Neither of them are particularly convenient. I know that both are kind of annoying to do, but at least you have options for how you want to be annoyed today. Yeah. Okay, any questions on this? Okay. All right, so let's talk about some trends really quick, okay? Because now that we're basically taking these problems and kind of computing them for different interest rates, we have some interesting phenomena that we can look at. Okay. Okay. All right. And so in this previous example, what we saw was that when we started from a negative or from a much lower interest rate, our present worth went from negative to positive. Okay. Okay. All right, and so if we plot it, and so let's say that we actually did, write the MATLAB code for this. Okay. Right, and so on the x-axis we have I, and on the y-axis we have present worth. Okay, and so if we were to plot this, it would look something like this, right? Actually, let me do it a different color just so to make it clear. Okay. Right, and so for lower amounts of interest rate, we end up with a negative present worth, but then for higher values of interest rate, we end up with a positive one. And the point on which the present worth actually crosses the x-axis, this is our true rate of return. Okay. All right. And so if we go back to kind of the cash flow diagram for this problem, right? Remember, for this cash flow diagram, we had a lot of positive cash flows early and then negative cash flows later, right? And so this type of pattern where we have benefits at the beginning and then we have negative cash flows later, this is the same pattern of a loan, basically. Okay. Right. Because if you think about a loan, right? A loan that you would take out for either buying a house or a car or for a school loan, right? You get a large amount of money at the beginning, usually in the present day, to pay for something, and then you pay it off slowly with negative cash flows later, right? And so for loans, what you'll see is that as you take your cash flows and you measure it across different interest rates, you're going to go from negative to positive. Okay. And so for interest rates that are lower than your true rate of return, you're going to get a negative present worth. And for interest rates that are higher than your rate of return, you're going to get a positive present worth. Okay. It might be cut off a little bit at the bottom, but basically all this says was just kind of what I said in words was, if you have for this is specifically for a loan, and so for a cash flow diagram that kind of follows that loan pattern, if you have an interest rate less than your rate of return, then you're going to get a negative present worth. Versus if you have a interest rate that's greater than your rate of return, you're going to end up with a positive present worth. Okay. And so you can kind of expect this trend for any loan, anything that kind of looks like a loan. Okay. All right. Any questions on this? Okay. All right, and so that's the pattern that you can expect for a loan. And so the opposite of a loan is an investment, right? And so for an investment, you kind of have the opposite trend, right? So investment is something that you pay out in the present day, and so you'll have negative cash flows early, but then that negative cash flow will turn into positive ones later. Okay. Okay, and so if you make the same graph for an investment type of system, what you're going to get is a present worth that goes from positive to negative. So you'll see the opposite trend. Right. And so, of course, the location where it crosses the x-axis, this is your rate of return. Okay. And then for interest rates that are less than this, you're going to get a positive, positive present worth. And then for interest rates that are higher than this, you're going to get a negative present worth, right? And so just based on, if you graph the present worths versus the interest rate for a certain amount of cash flows, you can use the shape of this graph to determine whether you have an investment or a loan. Okay. All right. Any questions on this? Okay. All right. And so that's kind of the introduction to how do we compute rate of return. So now let's talk about some common applications that you can use it for out there in the real world. Okay. All right. Okay, so let's start with a common situation that you'll come across, not only in your professional life, but in your personal life too. Okay, and so one situation that you'll come across is, let's say that you're about to make a big purchase. Okay, and so you're trying to decide whether you're going to purchase and buy and purchase it all the way up front, or if you're going to finance it through multiple equal payments. Okay. Okay. And so generally what's going to happen is that if you pay all up front, then a lot of vendors will actually give you a discount, right? And so let's say that a part will cost $6,000, right? And so if you agree to pay it all up front, then the vendor will be like, okay, I'll give you a discount on it, if you do that. Versus if you choose to finance it over a period of time, then you have to, pay the full price, okay? And so you can use rate of return to compute, how much or how good of a savings that you're getting by paying it all up front. Okay. All right. And so let's do an example that we can use to compare these two options. All right. And so let's say that you're considering the purchase of a $6,000 electric generator for your home. Okay, and so $6,000 is the sticker price. Okay, all right. And so after negotiating with the vendor, they said that if you choose to pay this all up front, then they're going to give you a 15% discount. Okay, and so they're going to, instead of $6,000, they're going to sell it to you for $5,100 of today's money. Okay. If you don't purchase it up front, what they say is that you can pay this over the course of a year in uniform monthly payments that are interest free. Okay. Okay. All right. And so what we want to do here is we want to compute the rate of return that we get by purchasing it up front. Okay? And then that's going to give us an indication of how much of how good of a financial decision that is. Okay. Okay. So any questions on the problem setup? Okay. All right. So let's go ahead and go to the next page. And so what we want to do is we want to compute rate of return comparing these two options. All right. And so let's start with the finance plan, right? And so with the finance plan, what they say is they're going to give us an interest-free payment, right? And so if it's interest-free, then all we have to do is we just have to divide the cost by by however many payments that we have. Okay? And so if we're going to do this over 12 months, which is a year, then we're going to take $6,000 and then just divide it by 12. Okay. And so we perform that, then we get $500, right? And so this $500, this is our uniform series. Okay? So this is our A. Okay. Okay. And so now that we have the uniform series, what we want to do is we want to compute the rate of return associated with the discount. Okay. All right. And so, one way that you can think of this is that, by choosing to pay up front, we are expecting to save money relative to the financing plan. Okay. And so the rate of return is another expression for how much money that we are saving. Okay. Because yes, it's easy to see that we're getting a 15% discount, right? And so that's that should already be seen pretty obvious. But we're comparing two different types of cash flow here, right? And so we're comparing one cash flow that's going to be in the present day, $5,100, versus a uniform payment of $500 each month. Okay, and so rate of return is kind of a way to think about, in terms of interest rate, and in terms of, making these cash flows equivalent, how much money that we're saving, right? Because remember, over the course, up front, of course, we're saving that $900 by off the cost of the machine. But what we're also missing out on is that, if we do choose to pay it over the 12 months, then we do save that $5,100 initially, and then we can invest that money elsewhere to earn some money. All right. And so that's why we do this in terms of rate of return, because the choice that you always are able to make is that whenever you save money in the present day, that's money that you can always invest elsewhere to earn more money as well. Okay. And so it's not that you're choosing between $6,000 versus $5,100, right? And I think most people can see that the difference between that is just $900. But it's a choice of, what else can you do with that money in the same amount of time, right? And so that's why rate of return is a little bit of a better metric of, how much money that you can save by paying up front. Okay. All right. Okay. And so what we want to do is we want to take our two options here and then basically set them equal to each other. And the way I'm going to do that is I'm going to take that $500 uniform series and then convert it to a present sum using the unknown interest rate. Okay. And then that interest rate that we find, that's going to be, that's going to be our rate of return. Okay. All right. And so what we have here is we have $5,100. This is equal to $500 times P over A, I, and 12. Okay. I'm gonna shift things around here. Okay. And then hopefully that'll make things a little bit more clear about why we're kind of setting this up, right? All right, so I'm going to move the $5,100 to the right side of the equation. Okay, and so we have a minus $5,100, okay, plus $500 P over A I 12. Okay. Right. This might seem like kind of a silly algebraic manipulation, but look at the signs that I've chosen for everything, right? And so for the option for paying it up front, what we have is a negative cash flow in the present day, right? And so that's what we have is minus $5,100, right? And then over time, by choosing to pay up front, another way that you can say it is we're saving $500 each month, right? And so we get one kind of big negative cash flow in the beginning, but then compared to financing it, what we had is $500 more each month later on, right? And so it's not that we're actually earning $500. It's just that we're having $500 more each month just because we didn't have to make those payments, right? And so when I put it like this, right, where we have a large negative sum in the beginning and a positive, cash flow that's happening later on in the series, right? This is the same pattern as an investment. Right? Right. It fits that pattern of having a large, negative cost in the beginning with benefits that are, that are happening later on. Okay. All right. Okay. And so this choice of whether you're going to pay upfront versus finance it over the several years or several months, you can almost think of it as an investment decision, right? And so, do we choose to invest in larger money now, and then get a benefit later, or do we choose to spread out the costs over time? Okay. Right, and so what we can do from here is that we can set up the present worth equations, okay, and then from there we can get the answer for this. Okay. All right. Any questions on this? Okay. Does that kind of make sense about how this whole thing is interpreted? Okay. Is it only a question? So is it only an investment if the second term is greater than the first term in the long run? Yes. And so, in order for it to be an investment, you have to, you have to kind of recoup your costs from the beginning. Yeah. Mm-hmm. Okay. All right. So let's go ahead and solve this for the interest rate. Okay. Okay. And so, since this is a fairly simple case, we don't have to do too much plugging in. And so I'm going to go ahead and solve this equation for the conversion factor. Okay. Right. And so if we move $5,100 to the other side, divide by 500, what we get is P over A I and 12. This is equal to 10.2. Okay. Right. And so since this is a fairly simple case, we can take the same approach that we did for the very, very first example we did for rate of return. Okay. And then we can just simply search the compound interest tables for a P over A factor of 10.2. Right. Okay. And so, normally you would have to search far and wide for this, but, just for the sake of time, I'm going to go ahead and kind of accelerate to the answer. Okay. And so let's say that we tested the this factor for an interest rate of 2.5%. Okay. And so 2.5% is on the tables, and what we get is 10.258. Okay. So this is pretty close, and so it's not quite there. We're off by a factor of 0.058. And so let's check the one above this, right? And so if we look at the P over A factor for I is equal to 3%, then what we get is 9.954. Okay. Right. And so what we see from these numbers is that the 10.2 that we have is right in between, right? And so let's go ahead and interpolate between these two. Okay. It's a little bit of a different interpolation than we did in the last problem because we're not interpolating present worths, but instead we're interpolating between these factor values. Okay. Right. And so if we perform that interpolation, what we get is 2.595%. Okay. And so it's something pretty close at 2.5, but it's a little bit higher than that because it's not quite. Okay. All right. And so the way that we can interpret this is that by choosing to pay up front, what we're essentially doing is we're earning money on an investment, and that investment has a rate of return of about 2.6%. Okay. All right. Any questions on this example here?
Could you explain again where the 10.2 comes from? Is that just something given to us, or did we find it from somewhere
Yeah.
else?
So the 10.2 came from solving this equation right here.
Oh, okay. Thanks.
Yeah. Mm-hmm. Yeah. All right. Any other questions on this example? Okay. All right. And so just a comment on this. A lot of companies, not just engineering companies, but I guarantee you Cal State Fullerton as a company faces this issue as well, is that, decisions like this are often made towards insurance plans, right? And so usually what the insurance companies will offer is that if you pay for the entire plan, for all your employees up front, then you're going to get a discount, and that's going to end up with a positive rate of return. Okay. Versus if you choose to space those payments out, then you have to pay a little bit more because of that, because of the the fact that the insurance company has to wait to get all those money. Okay. And so generally, it's if you can pay for everything up front and you know that you're going to use it, that's generally the more financially efficient decision. But a lot of times it's not that's not the only factor. And so a lot of times your company might need the capital, and so they might need the money to do other stuff like run the rest of the business, or maybe they just don't even have the cash just on hand at all. And so maybe they're waiting for like a big sale or something before they get some cash, but they need to make a purchase before that, and so they choose to finance it instead of paying it all up front. Okay. All right. And so that's one common situation where you can use rate of return in practice. Okay. Another common situation that you'll run into is whether you want to buy or lease equipment. Okay. All right. So let's do another example for that. And so in this example, let's say that we have a company that needs to purchase a machine to perform its work. Okay. Okay. And so they have two options. And so they can either purchase the machine. Okay. And so if they choose to purchase the machine, it's going to cost them $40,000. versus renting. And so they can rent the machine from the parent company instead. Okay. And the cost for renting is going to be $2,500 per month. Okay. Okay. And one nice thing is that if they do choose to purchase it, and they technically own it. Okay. And so in that case, what can happen is that you can then, the company can then salvage the machine. They can either sell it back to the company, or they can sell it to somebody else. And the salvage value is approximated to be about $6,000. Right, so this is something that you don't get from renting, because in renting you don't own the piece of machinery, and so once the contract is up, you have to give it back to the company, so you can't sell it to anyone. Okay. Well, I guess technically you can, but you're going to get a lot of angry people, a lot of lawsuits coming your way, which is usually not a good thing. Okay. Right. And so this company knows is that what they know is that no matter which option that they choose, they only plan on using the machine for 2 years. Okay. Okay. All right. And so just like just like our last example, we know that there's likely going to be some cost savings by choosing to purchase it up front. Okay. And so what we want to do is we want to compute the rate of return associated with purchasing up front. Okay. Okay. All right. And so, any questions with the problem setup? All right, and so let's set up a table to kind of summarize the differences in between these. Okay. Okay, this is going to help us visualize it a little bit. All right. And so the main differences that we're going to see are going to be in month 0, right? Months 1 through 23, right? Because we're using this for 2 years, and so we're going to use it for a total of 24 months, right? And then we're also going to see a difference in year 24. Okay. All right, and so if we lease the machine, we're going to have to pay $2,500 up front, okay? Because we have to pay the initial. We can assume that we pay in the month before we actually use it, right? And so it's just like renting an apartment. You pay at the beginning of the month to live at your apartment for the rest of that month, right? Okay. And then in months 1 through 23, then we also pay that $2,500. Right? So we're going to have a negative $2,500 in all those months. Okay. And then in month 24, we simply just return the machine, and so we don't have to pay anything, and so we just let it go. Okay. Okay. All right. And so let's compare that with buying. And so with buying, we have a cost of $40,000 up front. Okay. So that's kind of the large costs. In months 1 through 23, we're going to assume that there's no maintenance costs, or we're going to assume that the maintenance cost is the same for boats, and so they just cancel each other out. And so we have zero cost there. Okay. Right. And then at the end, we have a positive cash flow of $6,000 to represent the salvage value. Okay. Right. All right, and so for this problem, I'm actually going to do something, something a little bit different. Okay, and so what I'm going to do is I'm going to take the difference in between these two columns, right? And so I'm going to take what's on the buy column and then subtract it from the lease column. Okay, or other way around. And so we're going to take the buy and subtract the lease option. Okay, all right. And so if we do that for years, for month 0 right here, what we have is a minus 40,000, a minus a negative 2,500. And so in total, this is minus 37,500. Okay. We do this for months 1 through 23, and then what we get is a positive 2,500. Okay. And at the end, we have a positive 6,000. Okay. All right. And so the reason I do this, okay, the reason I took this difference here is that this kind of makes it really clear that, if we do choose to go with the purchase option, and so we choose to buy, then that is basically the same thing as performing an investment, right? And so this difference in between the two, this shows how much of an investment it is, right? And so between the two, we have a difference of an initial cost of $37,500. Okay. And then if we choose to buy, then each month after that, from months 1 through 23, then we save $2,500 in the rental costs each month, right? And so that's like a positive $2,500. That's going to be a uniform series, okay? And at the very end, because we can salvage the machine from purchasing it, we have a positive $6,000 for the cash flow, okay? Right. And so by taking this difference here, and the order that I chose for this difference was very deliberate. Okay, then we can kind of look at this problem of comparing the two as like an investment problem. Okay. All right, and so then we can actually use this, use this investment column or this difference, and then we can find the rate of return of that investment. Okay. Okay, so any questions on this? Okay. All right, and so let's go ahead and set this up like we did in the last problem. And so let's compute the present worths of both of these columns. Okay. And then set them equal to each other. So we're going to compute present worths of both options. Okay. And so what you'll see is that, when we do this and we kind of manipulate the equations a little bit, then we're going to get exactly the difference column that we have on the right. Okay. All right, and so let's start with the present worth of the leasing option. Okay, and so for the leasing option, we have a minus 2,500 present day sum minus 2,500 that we need to convert to the present day. And so this is P over A, I, and then 23. Okay, this is going to be equal to minus 40,000. Plus 6,000 P over F I, and then 24. Okay. Okay. And so all I did was I took our two columns of cash flows, I converted it to a present sum, and then I moved it, and then I set them equal to each other. Okay. All right. And so let's go ahead and manipulate this a little bit. So let's take all of the cash flows from the lease, and then let's go ahead and move them over to the right-hand side. Okay. All right. So if we do that, then we get 0 is equal to a minus 37,500 plus 2,500 times P over A I 23 plus 6,000 P over F I 24. And so if you look at the cash flows in this expression here, right? So we have a large initial cost of minus 37,500. Then we have a uniform benefit of 2,500 that takes place over each of the 23 months. And then we have a positive $6,000 that's occurring at the very end. Okay. All right. And so if you look at this and you look at the difference column that we had, right? This is exactly the same cash flows that the difference column represents. Okay. And so what we'll see next after this example is that whenever you're comparing options with rate of return, taking the difference in between the two is actually key towards towards actually getting a meaningful answer out of it. Okay. All right. And so now that we've set up this present worth equation here, what we can do is we can use it to solve for the interest rates. Okay. All right, and so since we have two conversion factors here, and so we have this P over A right here, and we have this P over F. Okay, we're just gonna have to start plugging in values for certain interest rates, and then just hope for the best. Okay. All right, and so let's start with I is equal to 3%. And so we compute the present worth of this PW3, okay, what we get is a minus 37,500 plus 2,500 multiplied by that conversion factor. And so that conversion factor, P over A, for I is equal to 3 and 23 months, then this is equal to 0.4919, okay, plus 6,000. Times that conversion factor. Oh, I'm sorry, I mixed these up. This conversion factor right here for the 2,500, this should be 16.444. Okay. I apologize for that. I was reading my notes in a little bit of the wrong order. Okay. All right, and so the conversion factor for the 6,000 should be 0.4919. Yeah, that makes a lot more sense. Okay. And so if we do this, then we get $6,561.94. Okay. And so we're not quite at zero yet. Okay. And so we know we're going to need to check other interest rates. Okay. And so it's at this point in the problem where you might be wondering which is the next interest rate that we should try, right? And so we can go two directions. So we can either go above this or we can go below this, right? And so we can either pick an interest rate of 2% and try that one, or we can pick an interest rate of 4% and try that. Okay. And so you might be wondering which is the option to choose. Okay. All right. And so think back to earlier in the class today when we talked about the general patterns for investments in terms of the present worth versus the general pattern for loans, right? And so for investments, what we said, if we can go back to that part, okay. For investments, what you have here is that the present worth starts out positive and then gets more negative as you increase the interest rate, okay. And so if we look back at the, at our present worth calculation for this one, okay, we can see that we have a positive number, okay, and we want to go in the direction that brings us closer to zero, okay. And so based on the shape of the investment, of the present worth curve for investments, we know that we need to start checking higher interest rates, right? Because that's going to bring us closer to zero, okay. All right, so let's go ahead and check I is equal to 4% then. Okay. And so for I is equal to 4%, I'm not going to write out the whole equation again, just for the sake of time. Okay. And so the present worth at I is equal to 4% is 1983 and 10 cents. Okay. Right. And so you can see that the present worth was less than the previous one, right? And so we're getting warmer, we're getting closer to zero. And so that information that we had based on the general trends for investments helped us out here. Okay. Right. And so now let's check for I is equal to 5%. Okay. And so PW at 5 is going to be minus 1916 and 90 cents. Okay. And so what we can see from this is that the sign is obviously changing, right? So we're going from positive to negative. And so from here we can interpolate. Okay. Right, and so I'll do the interpolation on the next page. Okay. Okay. So any questions on this? Okay. All right. So let's go ahead and perform our interpolation. All right. And so for interpolation, we need to plug in 4 values into the formula. Okay. So first, let's start with the interest rates. And so I low in this case was 4%. Okay. The higher interest rate is 5%. Okay. Right. Next, we have the present worths, right? Right. And so remember, this PW low and PW high here, these are the present worths associated with the lower interest rate and the higher interest rate. Okay, they're not necessarily the ones that are higher and lower. Okay, and so this is a good example here because because we have an investment and our present worth is getting more negative, then PW low here is actually going to be this positive 1983, right? And so PW low here is 1983.10. Okay, whereas our PW low is going to be a minus 1916 and 90 cents. Okay. Right. So remember, don't get those two mixed up. So you want to make sure that you're associating PW low as the present worth of your lower interest rate. Okay. All right. So now we have everything. So let's go ahead and interpolate. Okay. And so IRR here is going to be 4 plus 5 minus 4. Okay. And so that's I low, I high, I low. Okay. Then we're going to minus the PW low. And so PW low here is 1983.10. Okay. And on the denominator, we have our PW high, which is a minus 1916.90 minus PW low, which is 1983.10. But one too many nines. Okay. And so you plug all that into the calculator, and what you get is an interest rate of 4.51%. Okay. All right. And so that makes sense because if you look at the values for PW low and PW high, they're approximately the same distance, from the 0 point, right? And so one's about $2,000 over, and the other one's about $1,900 below. And so it makes sense that our interest rate here is kind of right smack dab in the middle, with a slight lean towards the higher one, which is 5%. Okay. All right. And so let's talk about the interpretation, right? And so remember, the way that we can interpret this is that if we choose to buy the equipment instead of leasing, then it's like we're doing an investment with a 4.51% return on that investment. Okay. Okay. All right, any questions on this example here? Okay. All right, so those are two, this example and the last one are kind of two good examples of, of a rate of return analysis in practice, right? So let's take kind of a step back and kind of look at kind of basically the same thing that we did for both examples here. Because, if we compare these last two examples compared to the one we did prior, both of these examples, we were comparing two different options, right? And so whenever you're comparing two different options with rate of return, you have to do this this step called incremental analysis, right? And so we kind of naturally did that with these two examples, but let's kind of formalize it in words just so that you know how to do it for the future. All right. And so basically, when we're performing comparisons, right? And so now we're kind of getting back into the same realm as like present worth analysis and annual cash flow, right? And so you can use rate of return analysis to perform comparisons. It's just that you have to set up the problem a little bit differently. Okay. And so when performing the comparisons, what we have to do is we have to take the difference of between them. Okay. Okay. Right, and then what you do then is you compute the rate of return of that difference. Okay. Okay. And what this does is this gives you a value of, or this, we call this value the IRR, which stands for the internal rate of return. Okay. Right. And then once you compute the internal rate of return, then you're going to compare that to another interest rate called the minimum attractive rate of return. Okay. Okay. Since the minimum attractive rate of return is kind of a mouthful, we often abbreviate it as MARR. Okay. Right. And so you can think of MARR as kind of like a threshold, right? And so, depending on if our rate of return is either greater than this or less than this, that's going to tell us which decision or which path that we should go to. Okay. All right. And so let me go ahead and break it down. Okay. And so let's say that our IRR, is greater than or equal to the MARR. Okay. Right. And so in this case, what we should do is we should choose the higher cost option. But if the IRR is less than the MARR, okay, then we're going to choose the lower cost option. Because whenever you have you're performing economic comparisons, most of the time there's going to be a difference in cost between them. Okay, so one's going to cost less upfront than the other one. Okay, and so when you're performing incremental analysis, then you can use that to determine whether you should go for the one that costs more or the one that costs less. Okay. And so this is kind of the table that you should, that you should remember for this. Okay. All right. Any questions on this before we jump into an example? Yeah, I know this is kind of a lot of text right now, and so I do want to do an example because I think that'll make things a bit more clear. With things like this, it's a little bit easier to illustrate some of the concepts through examples. But I have to kind of lay down a little bit of the groundwork before we do that. Okay. All right. And I know that we're almost out of time, and so I think just like last time, I'm going to start this example, and then we'll pick it up first thing on Tuesday. Okay. All right, question. So are there two different IRRs? And so for these kinds of problems, you only need to compute one, and so the only rate of return you need to compute is just for the difference. Okay. And so when you have two different options like this, you're going to take the difference in between them, basically exactly the same as what we did in the last example, and then you're going to compute the rate of return of that difference. Okay? It's actually unnecessary. You don't even need to compute the rate of return of each individual option, because what you'll see in the next example is that actually gives you some misleading results. And so you need to compute the one of the difference, and then that's the one that you roll with. Yeah. Okay. So let me go ahead and start this example, okay? And then we'll pick it up on Tuesday. Right. And so the numbers for this example are pretty straightforward, just because I'm just using this as an illustrative example. Okay? And so let's say that we're considering two different investment options. All right, and so these are 2-year or 1-year investments. Okay. 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 And so option 1 is going to cost $1,000 in the present day. Okay. But 1 year later, through some kind of magic, you're going to get $1,500 back. Okay. Option 2 is going to cost $2,000. Okay. And then after 1 year, you're going to get $2,800 back. Okay. All right. And so for this problem, let's assume that we have an MARR of 10%. Okay. All right. And so let's compute the rate of return of each individual option first, and then we'll leave it at that, okay? Just because it's pretty fast. Right. And so normally you don't do this, but this is kind of just for an illustrative example, right? So let's find the rate of return for the first option. Okay. And so this is going to be minus 1,000 plus 1,500. Okay. And since this is a pretty simple case, I'm just going to plug in the formula for this, right? So normally we do a P over F factor for n is equal to 1 year. Okay. But since it's just n is equal to 1, we can just plug in for it. Okay. And so if we solve for I here, we get I is equal to 50%. Okay. Right. Which makes sense because our money grew by 50% of our initial investment. Okay. Okay. And so option 2, we have 0 is equal to minus 2,000 plus 2,800 times 1 over 1 plus I. Solve for I, we get I is equal to 40%. Okay. And so from these numbers here, you would think that option 1 is the better one to do because you get a higher you get a higher rate of return, right? And so you get, your money multiplies more in option 1 than you do in option 2, okay? But what I'll show you next week, and so, on next time on Dragon Ball Z, I'll show you that actually option 2 is the one that you're gonna want in this case, okay? And so it's a bit of a cliffhanger, I know, but hopefully that curiosity gets you going over the weekend, and then we'll talk about it on Tuesday, okay? All right, so any final questions before we wrap up for today? Okay, right, so thank you guys for tuning in today. I know I stayed 1 minute extra, so I apologize for that, but hope you guys enjoy your weekend. You can look forward to the review video tomorrow going up, and I will see you guys next week.
All right, thank you, Dr. Chen. Have a good weekend.
Thanks, you too.
Professor, I have a quick question.
Sure, what's up?
So in the homework, it does have a question that covers capitalized costs. I was wondering if you can kind of go over a quick example, because I wasn't able to understand the question.
Sure. And so for capitalized costs, remember we have this formula here where A is equal to IP, right? And so, the capitalized cost is actually this present sum right here, right? And so when I asked you to compute that for a problem, what you have to do is you have to do A divided by I, right? And so the question then becomes, what do you choose for the A in these kinds of problems, right? And so for the homework problem, I believe what I did, let me pull it up real quick. Not this one. This one, right? So you're talking about the one with the department store, right?
Yeah.
Yeah. And so for the department store, in part 2 of that problem, I asked you to compute the equivalent uniform annual worth of each option, right? Or in other words, EUAW, right? And so what form of cash is EUAW in, right?
Yeah.
It's a uniform series, right? And so all you have to do for part 3 of that problem is to take your EUAW, plug it into this formula, and then just divide by the interest rate.
Oh, okay.
Yep. So for capitalized cost problems, the formula is, as you can see, really simple. The question is, what do you plug in for the A? And for most cases, it's going to be the equivalent uniform annual worth for that. Yeah.
Okay, and that's it?
Yep, that's it.
Okay, all right. Thank you, Professor.
Yep, no problem.
Sorry, Professor, I have a question.
Sure. Mhm.
Can you go over the investment diagram one more time?
Sure.
Because based on what's written, you said investments, we have negative cash flows early and then positive cash flows later.
Yep. Mhm.
But it looks like it's the bar of rate of change. It's going from a positive side to the negative side. So I got a little confused.
Yeah, and so the x-axis here is not time, and so I think the x-axis here is interest rate, right?
Right.
And so for investments, you're right. For investments, we have negative cash flows early and positive later. But then when you compute the net present worth from all that, then the present worth will depend on what interest rate that you have. Yeah.
All right. Thank you.
Yep. Mm-hmm. All right. Did you guys have any other questions? Mitchell, Chris, Janelle? Okay. All right. And so if you have any other questions, you can go ahead and email me. But if not, have a great weekend. See you guys next week.